Welcome to Binomial on the TI-84 Plus, and these are pretty much the same for TI-83, any comparable calculator. I want you to start out and press that second key, and then find the VARS key. It has DISTR. We want to press those two, and you should get this screen. Initially, you only see this much, but if you keep scrolling down, you can get to line A and B, which is Binom PDF and Binom CDF, and that's what we're going to be working with on this video. Be sure to press second, VARS, and you can scroll up or down, it doesn't matter, until you find lines A and B. The binomial distribution, you have a number of trials, N, you have a probability of success, P, and then you have an X value, which is the number of successes you're interested in having. Notation-wise, we would write the probability of 8 successes, we would write P parenthesis X equals 8. Now let's say we had 20 trials and the probability of success is 70%, 0.7, and I want to know the chance of having exactly 8 successes. For example, probability you survive some surgery is 70%. The doctor's going to perform 20 of those surgeries. What are the chances exactly 8 patients survive? Not 9, not 7, exactly 8. That's what we want to calculate. Now, calculating that by hand isn't a whole lot of fun. However, the calculator does it just fine. So we're going to type second, VARS. We're either going to scroll up or down until we get line A, Binom PDF, and enter on that A. Now, if you have a TI-84 Plus, it will ask you trials, and we have 20 trials. We want to put a 20 in there. It will ask you the probability P. You want to put a 0.7 in there. And it will ask you the X value. How many successes did you want to have? And we wanted to have exactly 8. And then we arrow down and enter on calculate. Notice when you get to your home screen, what you see on the home screen is Binom PDF, and some of that might have run off the page. And it has parenthesis 20, 0.7, 8. If you have an older calculator, when you press Binom PDF, you'll just have Binom PDF on your screen with a parenthesis, and you have to learn it wants N first, it wants a comma, the comma key is right above the 7. I probably should have drawn that out here. Then it wants your probability of success, P, and another comma, and then it wants the X value you're interested in. And close your parenthesis. The parenthesis close is right above the 9. And we hit enter, and it tells us this is 0.00385, etc. If I wanted to round to the 5th decimal point, that's 5 and then 9. So I would have to round this guy up to be 0.00386. If I wanted to round to the 6th decimal point, I'm going to need to look at all my decimal places. If I want to round to the 6th decimal place, now my next digit is a 2, and so we would say 0.003859. I'm going to be kind of picky about your rounding, because if you're in statistics class, you should know how to round to a decimal place. Well, what if we wanted to know the probability no more than 8 survived? That would be 8 or less. That's the probability X is less than or equal to 8. That's binomial CDF. CDF is less than or equal to, so it's usually more than one value. I think of the P as standing for personal, just one value, and the C as standing for crowd, more than one value. Technically, PDF is probability density function, and CDF is cumulative distribution function. But personal and crowd work for me. So we want to hit second vars. That accesses the distribution function. Then we want to scroll up or down until we find binomial CDF. And it's going to want everything in the same order. So our number of trials is 20. Our probability is 0.7. Our X value is the 8. And it knows, since we asked for CDF, that we're interested in less than or equal to. And so our calculator will show binomial CDF 20.78, close the parenthesis, and this gets us 0.0051 if I round to the 4th decimal place. So the probability that X equals 8 was 0.0039. The probability that X is less than or equal to 8 would have to be more than that, because it would include the probability of X equaling 8 and the probability of X equaling 7, 6, 5, 4, 3, 2, 1, or 0. And sure enough, it is. That's binomial. Now, our calculator only does equal to or less than or equal to, but that isn't always what the problem asks for. What if we wanted to know, find the probability at least 8 survive? Well, that's the probability x is greater than or equal to 8. And our calculator doesn't know how to do that. But let's think about the choices. All the values x can be 0, 1, 2, 3. One solution would be to do binomial PDF on each one of these for 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, and add them up. Ooh, we could do that. I'm not looking forward to it, though. Or the sum of all probabilities equals 1. The probability x equals 0 plus the probability x equals 1 plus the probability x equals 2, on and on and on, out to the probability x equals 20. That's 100%. That's all the ways this 20 surgeries can end up. That equals 1 or 100%. So the probability x equals 8 plus the probability x equals 9, on and on and on, out to the probability x equals 20. That would equal 1 minus those probabilities that we don't want. This is what we don't want. So if I take 1 minus that, I get what I do want. 1 minus the probability x is less than or equal to 7 equals the probability x is greater than or equal to 8. Oh, my calculator will do the probability x is less than or equal to 7. I want 1 minus binomial CDF 20.77, and I get 0.9987 if I round to the 4th decimal place. This is a really good trick, and we're going to use it a lot. 1 minus what I don't want equals what I do want. And that's all there is to binomial. Good luck.